Hello, my name is Emily Ehrlich. I'm a Kennesaw State University graduate student working towards my Master's of Computer Science. I am working as a graduate research assistant under Mahmoud Kadakaya, where we are researching off-angle iris recognition techniques. Today I will be giving a brief presentation on the analysis and comparison of two different approaches to off-angle iris normalization. The first being elliptical unwrapping and the second frontal projection with circular unwrapping. Among the different biometric solutions, iris recognition has been referred to as the most reliable due to the iris pattern's distinctiveness and accuracy. However, the captured iris image determines the accuracy of the recognition systems. In our experiments, we use iris images of the left eye from 78 subjects captured at different gaze angles ranging from negative 50 degrees to positive 50 degrees, shown in the experimental setup. We capture these images for testing purposes at 10 images per angle, with a total of 110 images per subject. The methods section illustrates the two different approaches to recognition of off-angle iris images. The difference in these two approaches is in the normalization step. The blue box at the top of the fork represents the elliptical unwrapping approach, with the yellow boxes at the bottom of the fork representing the frontal projection with circular unwrapping. Both approaches use the rubber sheet model when unwrapping the image. The rubber sheet model takes the segmentation points and unwraps the iris counterclockwise. In both methods, the size of the normalized image is set to 64 by 512. We start sampling from the 3 o'clock position with the origin at the sclera center, so 64 linear points are selected between the pupil and sclera boundaries, with the same distance measurements. This procedure is repeated 512 times, increasing the sampling angle approximately 0.7 degrees. The key difference between the two approaches is the extra step taken in frontal projection. Before the image is normalized, it is first projected back to the frontal view using the ellipse parameters, resulting in a circular iris image, which is then normalized. Finally, we compare the Hamming distance and ROC curve for elliptical unwrapping and circular unwrapping with the frontal projection. The ROC curve demonstrates the true positive rate and false positive rate for different Hamming distance thresholds. The results showed that the elliptical normalization method shows slightly better recognition performance in off-angle iris images, with a 2.2% decrement in the equal error rate, represented in the graph under results. This research demonstrates that elliptical unwrapping showed better performance on off-angle iris recognition.